Hi, good morning and good afternoon, everyone. Thanks for joining us today for this new webinar by Severalnines. My name is Jean-Jérôme, and I'll be looking after you for the next hour or so. Thanks for joining us today. Before we get started, just a few items I wanted to cover. First of all, from a logistics perspective, you can ask us questions at any moment during this webinar by using the question section of your control panel. You can also use the chat box if you want to contact us. During the course of the webinar to ask questions about the content that you're seeing, but also about the system itself. So feel free to use those options to get in touch with us over the next 60 minutes. You can also email us at jj@severalnines.com. That's my email address, and we'll look after you from there if you have questions during or after the webinar, if you want to continue some discussions afterwards. So that's jj@severalnines.com. And just before we get started with today's topic, which is all around backups, I wanted to give you a quick introduction on Severalnines and our product ClusterControl. We are a company that specializes in the automation and management of open source databases, where we focus on these four main areas, which is the deployment, the monitoring, management, and scaling of these databases. ClusterControl is a product that comes in two flavors. First of all, there's a community version where you can deploy and monitor for free and for as long as you want. And there is an enterprise version also that includes management and scaling features, which you can test as part of the download process when you first access ClusterControl as a download for 1 month. You can see here some of the key features of ClusterControl around provisioning, around monitoring, around management. You can deploy on-premise or in the cloud. There's a lot of monitoring features that you can see here that you can use and have access to via the community version. And then there's a whole range of management features which are accessible to via the enterprise version, from database upgrades through to cloning. These are the databases that we support, all of the different MySQL versions that exist today. MongoDB, also in the two versions by MongoDB and by Percona. And we support PostgreSQL as well. We have about 12,000 users to date, some of which you can see here, some of our customers who are listed here that range from all of the different industry types that you can think of, different sizes and so on, were being used by quite a few people who use ClusterControl to automate and manage their open source databases. But today is all around backups and how to best proceed with them for MySQL, MariaDB, and Galera cluster. And of course, we support backups as well with ClusterControl. But today it's all about best practices on how to go about backing up your data in the best way possible. My colleague Krzysztof Książek is going to present today and also do a live demo towards the end of the webinar. And to kick things off, I wanted to ask all of you a quick question. And this is to understand which environment you currently use yourselves or have your databases in at the moment, whether it's in cloud hosting, or whether you're hosting data centers, whether it's on premises, whether it's a mixed environment, maybe also, or something else. It'd be great to get your feedback here, just to get an understanding of how you currently host your data and your databases. So I give this a few seconds for everyone to participate. And I'll share the results, of course, also, so you can see what the split is today within our audience. And then we'll get started with today's topic. So thanks for your participation. I'm just going to close this now and share the results. Okay, so it's a 50-50 split, which is interesting to see, between data center hosting and on-premises. That's interesting. And so I guess no actual cloud hosting, no mixed environments. Maybe this that mix could also stand for that. Krzysztof, any comments on this before you take over?
Yeah. So definitely it is interesting to see this kind of. Interesting to see that there are no cloud users, but still, most of the tips, the techniques that we'll be talking about, the tools that I will be talking about today are relevant to any of the infrastructure. So I'm pretty sure that all of you will benefit from having this webinar with us.
Great. Thanks a lot, Krzysztof. And with that, I'll hand over to you for the presentation.
Okay, thank you, JJ. So good morning, good afternoon, everyone. My name is Krzysztof Książek, and as JJ said, we will be talking about different tips about how you can backup and how you should backup your MySQL, MariaDB and Galera cluster instances. So first of all, I will be talking about backup types, different backup types. Then I'll talk a little bit about the tools that can help you and that can be used to get a backup. I'll share some good practices and discuss some example setups. So how your backup strategy may look like in a particular environment. And at the end, I'll give you a quick demo of the backup management features of the ClusterControl. So the backup types. So in general, we have two backup types. First of them is our logical backups. So by a logical backup, I mean a backup which generates a plain text file. So it's either a file which contains SQL commands, it can be comma-separated value, it can be tab-separated. It's just a common. This is a plain text file. You can, a human can read. Typically, you use some sort of SQL commands to load the data from such file. So it's either containing the file, it's either containing like inserts, then you just run inserts, or if it's a comma-separated value, or in general some sort of something separated, like tab separated, space separated, semicolon separated data, then you use load data in file command. The fact that this is you have all of this data in a human readable format, sometimes it's hard to read, but it is possible to do so still. It gives you the ability to recover even a single row, because if you're talking about the inserts, then all you need to do is just find the correct insert, or find the insert multi-value set which contains the particular row that you are interested in, and then just get it out from this insert. For comma-separated value, for tab-separated files, you just have to find the row which contains the value that you need to recover. So it is very good. I mean, it's a very important feature of those types of backups, which is kind of unique to the logical backup. So in the past, it used to be must-have for major version upgrades. So if you're upgrading 5.5 to 5.6, for example, it was required to. I mean, the only supported way to upgrade was through dumping the data into logical backup format and then loading it back. This changed in MySQL 5.7, where binary upgrade from 5.6 is a supported method. It's hard to tell if it's just one-time change or Oracle will try to keep it like that. I hope they will try to keep it because it will make things much faster. But as of now, we just never know. It's also critical. I mean, also important methods if you want to move data between MySQL flavors, because sometimes there are some binary incompatibilities between MariaDB, Percona Server, Oracle. It's not common, but it may happen. In that case, the safest way would be just to dump the data in a logical backup format and then load it back. mysqldump, I think, is the best known backup tool for MySQL. It has the ability to dump tables, dump schemas. It can, as all logical backups, it gives you ability to recover even a single row. And even if it's easier with extended inserts to 0, but where you have insert per row. But even if you have extended insert enabled, it's still possible to get this single row and then restore it. mysqldump, it said that it causes locking, but it's not really the case. Like if you're running InnoDB, it's not different than other backup solutions. Some lock has to be taken always if you want to have a consistent backup, but other than that, that's just fine. The problem with mysqldump is that it tends to generate SQL files, large SQL files. It depends on the data, but just like sometimes even 2 and more times. The size is two times bigger than the physical volume of the files, size of the files on the disk. Therefore, you want to dump separate tables. So if you're dumping a schema which is like 100 gigabytes or more, you don't want to have like 150 gigabyte of SQL dump file. You want to split this in tables to make it more manageable, to parse, to restore, to move around, to find this single row, and so on and so forth. It can be used to build a slave. There's a master data flag which gives with which the MySQL dump will collect and store the master data in file. The change master 2. This will be basically put into the MySQL dump file. There's long recovery time because MySQL dump stores everything in insert format. So to restore it, you have to just run all of those inserts into MySQL. So it involves parsing of the SQL. It involves loading the data and checkpointing and all the in MySQL DB internals that are sometimes limit the performance of the database. MySQL dump is single-threaded, so technically you can run it in parallel on per table basis. So if you dumped a couple of, if you dumped file per table in a way, then you can basically write some sort of wrapper like Perl, Python, whatnot, and that spawn several workers, and each worker will start to import one file into the MySQL database. So you can parallelize it somewhat. There's quite a new tool, MySQL Pump, which is like an extension of MySQL dump, which can be used in parallel. But it's still pretty new software, and if you had some experience with it, then please do share with us in comments. But still, the MySQL dump is the most popular one so far. If you live outside of the Latin 1 world, if you have some sort of separate character sets for your data, your native language, or the languages that your user uses, and it's not UTF, then the conversion of the loading the data to some other server can be tricky, because you have to make sure that all of the character set settings match correctly. In the file, in the dump, in the table, in this database, sometimes even in a shell. So this could be tricky. And MySQL dump definitely is not the fastest method to take a backup and restore it. Selecting to OUTFILE is a separate method available in MySQL dump. So you can run MySQL dump with some command, some flag, and then basically execute select into OUTFILE. It's faster because there's less overhead to restore the data. It's also more tricky to restore because especially if you get a file dumped in some unknown environment, maybe some different operating system, like maybe you have a MySQL running on Windows and someone runs select into OUTFILE, and then you try to insert it on the Linux box. This could be tricky. Of course, everything is doable, but you have to play with all those terminated by, separated by settings, and this is just quite inconvenient. And selecting to OUTFILE, you can use it to generate CSV files, which are basically standard method of moving the data between different type of databases or spreadsheets. You can dump data from MySQL into comma separate value and then load into Excel or whatever. Everything creates CSV files. mydumper, myloader. There are tools which are slightly comparable with MySQL dump, but there are some differences. Namely, they allow parallelization on per table basis, on a lower level than per table. So they split tables in chunks, and then you can use multiple threads to work on the same table. It used to be hard to install and use, but since like 2-3 years, Percona started to maintain the code, and they made some nice improvements. So right now, mydumper supports GTID. It supports dumping of schemas, routines, triggers, events, and it hasn't been the case like as I said 2-3 years ago. RPMs are available and they do work, so it's much easier to set this up. So right now it's just basically on par with mysqldump when it comes to the features, and it's faster because it allows some parallelization. Dump time, from my experience, of course, I mean, your mileage may vary, and it will vary, but from my experience, 1 terabyte of data dumped in 4-6 hours, which is quite nice. Of course, loading time much longer, but it's still faster than mysqldump. And this is, and there's the fastest logical backup that I know. So if you're required to do some sort of logical backup on large data set, you may want to look into mydumper and myloader. Physical backups. So physical backups work slightly different than the logical ones. So they generate an exact copy of the data. So it's not like taking copying the contents. You just copy the whole data in a binary way. And given the fact that they just copy the files, they tend to work on high level. It's not always the case, but that's how some of them, like majority of them, I think, works. So it's either restore all or nothing, right? You either copy everything back and create a new MySQL using all of the data, or you cannot restore it. It's definitely the fastest way of grabbing a copy of your data and fastest way of restoring your data, because you are not limited by MySQL, you're just limited by the hardware. So disk speed, network speed, if you are streaming the data to some other location. So it's just, if you can, it all depends on how fast your disk can copy, let's say 1 terabyte of database, right? And usually it's much faster than hours, and to restore is the same speed compared to, and so it's much faster than like hours or even days for logical backup. And as given the speed, and it's just great tool, great way to build the infrastructure. Because if you build the infrastructure, if you provision and you slave, usually you want all of the data anyway. So this is not a limitation. Extra backup. So I think this is the backup solution as of now. It's online backup for InnoDB tables. It's like almost virtual in unlocking. But as I said earlier, every backup has to take some logs at some point if you want it to be consistent. So some logs are still being taken. So how it works is it copies the data files, the table spaces in InnoDB, and in the same time it's logging transactions which are happening in the meantime. So it just parses, it scans read logs and checks if there are any transactions, that's any new writes that are being done on the MySQL, on the InnoDB. If you have MyISOM tables, the log would be more severe because all of the traffic has to be, all MySQL has to be logged for the duration of time required to copy the MyISOM files. I mean, the solution for that is not to use MyISOM, because right now it's not really, there are just really handful of use cases where it makes sense to use MyISOM. Other than that, you just stick to InnoDB and you'll be all good. Extra backup supports local backups. It also supports streaming over the network. So you can stream directly your backup from your own MySQL database, MySQL server to some backup host. It supports incremental backups, so you can take a full backup like once per day, and then you can take backup, just incremental backup every, let's say, 3-4 hours maybe. To use backup, it has to be prepared. So the transactions from the log, from the ladder log, have to be applied. And if you're applying logs, if you're running this apply log command, remember about use memory argument, where you can pass the memory that in a backup extra backup can use to apply logs, and basically it just speeds things up to give it more memory. Extra backup is the exception from the logical backups, from the physical backups. So it supports partial backups. It supports backups on per schema and per table basis. No, not only per row, but at least per table. It's not perfect because you cannot take a consistent backup and then just like restore a single table, but it's still helpful under some circumstances, especially when you're restoring missing data. So instead of just copying everything, you can copy one table and then restore it. And then dump, let's say, missing row or missing subset of rows, and then load it to the production server. Extra backup can bundle replication information with the backup and can bundle Galera sequence number with the backup. So it's quite easy to use it to provision a slave or to provision a new Galera node in a Galera cluster and avoid SST. So for example, I mean, technically SST is also extra backup, but what I'm saying is that, let's say you're already taking a backup on a daily basis. So then if you have this backup and if you provision a new Galera node quite fast after the backup is completed, like within the IST window, you can avoid another extra backup, this time executed by SST process, to put some load on the production cluster. Snapshots, and by snapshots I'm talking about different type of snapshots. So LVM, EBS if you're in the cloud, SAN snapshots, anything. They grab the whole data at once, the whole disk, the whole volume at once. Usually snapshots are quite fast to take, and they're really nice to build infrastructure in the cloud, because you just take the snapshot, then you build a volume out of the snapshot, and then you attach a volume to instance, and you have another slave almost. Just bring it up, configure the replication, and that's about it. It's not so great for recovering small pieces of data, because again you have to provision a whole new host with a new volume and so on and so forth, and it takes some time. But well, that's how it works, unfortunately. With snapshots, you have to keep in mind that they have to be consistent to be useful. So in general, there are many ways you can enforce consistency. So you can, for example, run InnoDB /log ** commit set to 1, which will slow down your InnoDB operations, but it will make it crash-proof. You can run a flush table with readlog, and this will work for all engines, but still you have to go through the InnoDB recovery process. So the whole problem with the snapshot is that it's just like it's taking the disk as it is in this given point of time. So basically it is the same as if you would just pull out the plug and stop the whole physical server at the given point of time. So to bring back MySQL, InnoDB has to go through the recovery process. And there is no way around it. So it will slow down in the first start, but it is required. So what is important is that you won't lose any data while you're just pulling this plug, like while you are taking this snapshot. That's why I was mentioning the full durability with /log * commit set to 1. If you happen to have free MySQL server, free MySQL slave, which can be used, which can be stopped from time to time, you can take the code backup, which is fully consistent, because you just stop the MySQL, making sure that there are no fast shutdown enabled. So everything is flashed to disk, and then you can take this disk snapshot, you can start MySQL again, and everything will be nice and clean and how it should be. But you have to stop this MySQL at some point, and this could be a problem. EC2 Consistent Snapshot is a tool which can help you to implement snapshots in EC2. It supports cold backup, so it can stop MySQL for you and then take the backup. It can use flash table with read lock. It can run fsfreeze and xfsfreeze commands to freeze the file system. It also can write at volumes. So I'm talking about a case where you have multiple EBS volumes attached to the instance, and then you have software RAID on top of them. Right now, it's not that probably common. It used to be much common in the past, where when we had lower limits in terms of the IOPS per volume, per EBS volume. Right now, you can assign more IOPS to provisioned IOPS to the volume, so it's not that needed. But in case you have it, that's EC2 Consistent Snapshot can help you. And now let's talk a little bit about the point-in-time recovery, which is basically the must for a database. Like, this is critical to have it. So backups are taken at a given time. So what happened? How to recover data which was removed between the backups? Yes, and how not to lose the progress that you made during the time. So let's say you have a backup at 1 a.m. or let's say 2 a.m. and then some data was lost at 1 a.m. So basically, you need to recover. I mean, you can recover from the previous backup, but then you will lose like 23 hours of the production. So you have to do something about that. And binary logs can be used to replay changes, because I mean they are used to replay the changes on the slaves, so they can be used also to replay the changes which happened between backups. So what you want to do is you want to use MySQL binlog to convert binary logs, which are in obviously binary format, convert them into SQL format. And once you have the binary logs in SQL format, you can go through a process which may sound complex, but once you go through it once or twice, you will see it's pretty straightforward. So what would you need to do? So you need to restore a backup prior to the data loss. So you recover the backup from 1 a.m. The previous day, or 2 a.m. the previous day in our example. Then you just find the position where the backup was taken. XtraBackup, for example, stores it in XtraBackup binlog info, but you can also run show master status for snapshots, for example, and then take the position. Run MySQL, then you need to just dump the data from MySQL using MySQL binlog, starting from that particular position until the end of the binary logs. Find the point of the data loss. So let's say drop schema or delete from, which caused the problems. Find the point, the transaction before when it happened. Restore everything starting from the point of the backup until the point directly before the event, the data loss event. Identify position after the data loss event, and then again reply all of the SQL that happened after the data loss event until the end of the binary logs. As I said, sounds scary, but once you go through it, it is quite simple process. Time-consuming, manual, but it is possible to recover the data quite nicely, as long as you have binary logs enabled. Good practices. So first of all, we want to, you want to ensure that backups are being made, right? So personally, I think that the best time to do that is during health checks, because when you run MySQL in production, usually you do some sort of daily, weekly health checks. You go through the health of the system, you make sure, you review the logs, review the performance metrics, make sure that everything is fine. And that's a good time to check also the backups. So you want to ensure that backups are actually being made, so the backup files are being created and streamed to backup host and whatnot. You want to ensure that the size of those backup files makes sense, because if you have 50 gigabytes of the data set, then if the backup file is of like 2-3 megabytes of size, then most likely something went wrong. So you want to investigate what happened. You want to also check that the logs are clear from the errors. So you want to collect, when you run the backups, you want to collect the log from the process, and then review it, because it may happen that the size might be just more or less fine, but just towards the end, like 99.9% completed, but then something failed. So you won't catch it up from the size difference, but you should be able to notice that something is not right when you go through the logs of the process. And you want to automate this process to make your life easier, because, well, it's again something time consuming. So if you can integrate it to some sort of automation process, that would be really nice. And actually, if you use ClusterControl, you can benefit from backup reports, which is part of one of the operational reports that we allow you to create and schedule. And this basically gives you some sort of summary information about different backups. Did it completed, the storage location, the size? So it is just like you have some sort of overview of what happened in your cluster. So then we are checking on a regular basis, like daily, weekly basis, we're checking the state of the backups. But the problem with the backup is that each backup is a Schrodinger backup. So basically, you don't know, you are not sure about the condition, whether it's good or not backup, until you attempt to restore it, because the backup can be done, but for some reason you may not be able to restore it. So therefore you need to do restore tests. It should be done regularly, like depending on your requirements, depending on your load. Can be every month, twice per year, depends, but it should be done. Like, of course, more often, safer. You should also make sure that you make this restore test after any changes in the backup process. So let's say you want to add some sort of compression, maybe, or switch from switch to some parallelization from zip to pixzip, for example. Just make sure that you do restore test afterwards to make sure to see it actually works just fine. Because all of the different things may happen. If you encrypt the backup, maybe you don't have, for some reason, you don't have the access to the key, which you need to recover to decrypt the backup. All of the different things can go wrong. So you should cover the whole process of recovery. You want to decompress and decrypt the backup if it is there. You want to, to build a new instance using this data and start it to make sure that you actually can start a new provision and start a new MySQL server using the backup, the data from the backup. You want to slave off this this new server, slave this server of the master or of the one of the slaves where the backup was taken from, to ensure that you can set up the replication and then the replication can actually work fine. Sorry for that. And ultimately, you could even try to use PT table checksum to make sure that the backup, the slave that you created from the backup is consistent with the master. So more steps you take to ensure that you're fine, the more certain you can be that you are indeed fine, and in the worst case scenario, you can recover the process. And in the development version of ClusterControl, so in the next release, we hope to deliver an automated way of verifying your backups. So you'll be able to basically pick a host, and the ClusterControl will attempt to restore backup on that standalone host. So I'll show it a little bit in a demo later on. Disaster recovery plan. So first of all, you have to have one, because when things go really badly, then you want to have some sort of plan how to proceed and how to recover from this disaster. You want to store your backups outside of the main data center. That's pretty obvious, because if your main data center goes up in smoke, you want to be able to restore your data from in some other location. You want to assess the time needed to transfer the data back and recover it. So this is because, well, it would just give you some estimates on when you, in a case of total data loss, you'll at least have some idea of when you would be able to go back online. Makes easier to plan things, makes easier to communicate with the users, so on and so forth. And it's important that you have prepared detailed runbooks, step-by-step runbooks, what to do and how to recover your data in case of total data loss. Because the problem with that is, if in this case everything is really, everyone is nervous, everyone is like panicking, and everyone try to to tackle 10 things at once, because, well, you have to tackle 10 things at once to actually make it fast. So you either stick to the runbook or you will make mistakes. And making mistakes in such a moment is, well, not the best idea, because it can postpone the recovery for next X hours or so, or X days. So the step-by-step guide how to recover, copy-paste commands. This is the best way of how you can prepare in case of really disaster hits you in your data center. Okay, so let's talk a little bit about example setups now. I will talk about two of them, one on premises, second in cloud. So on premises, I would stick to xtrabackup. So full backup daily, incremental backups every 4 hours. So then what is quite important, of course, like disclaimer, your mileage may vary, your mileage will vary, and it's not like this is the ultimate, just you have to do it like that. Everything depends on the data size, everything depends on your infrastructure, so on and so forth. So it's not always what I propose here is feasible in your environment. But still, there's just some sort of like the basic setup that you can build upon. So Ideally, you would store the data locally on the database server and then copy it to some sort of separate backup server. This is because, well, when you need to recover something, of course, you want to make it quick. So if you have a means to store the backup on the MySQL server, in case everything goes up on the server, you can easily recover it using one of the backups locally. So no network traffic involved. And copying the data over the network obviously adds some time to require some more time because disks are faster than the network. So that's why ideally you have some sort of backup copy locally. Ensure that you make a copy of binary logs because you will need them for the point time recovery. And everything combined together. So I'm talking about this full backup daily, then like several incremental backups every now and then. This should make it quite fast to recover, and then you won't have to recover like whole day from the binary logs. So at most like 4 hours, which should be quite, manageable. Again, depending on your workload, depending on the size, the amount of the writes that you're doing. But for most of the cases, this should be manageable. If you use LVM, if you can use LVM, that's fine. This is also quite a nice way of taking the backups and quite fast way of taking the backups. If you have additional server available, like ad hoc queries or some sort of development server, which has the production dataset, you can use it just to set up backups on them. So you can set up either a VM, then run cold backup, so stop MySQL, run the VM snapshot, bring it MySQL backup, or you can use it for logical backup. So you can run MySQLDump on it, and thanks to that, gain the ability to recover, even a couple of rows when someone messes up the delete command. And of course, copy data offsite for disaster recovery. Cloud. I'm talking about AWS, but cloud in general. Cloud which allows you to some sort of block level snapshots. So usually you'll focus on EBS snapshots, which is really great. The problem is that it's hard to take it frequently because it takes some time to complete. So if you have requirements that you need to take a backup every, let's say, 5-10 minutes, you may need to stick to xtrabackup. And this is actually quite, may sound weird, but I've seen this kind of setups and they actually work quite well. So just take a full backup like every now and then incremental backup every 10 minutes, for example. If you use the software setup on top of EBSs, you can use EC2 consistent snapshot, if you will. Of course, copy the snapshot to a different region for disaster recovery. So East Coast, West Coast, the Amazon command line tools to do that. And this basically gives you an ability to easily create provision a new instance on some other location, like on the opposite side of the United States or opposite side of the world, if you need be. And again, likewise with the on-premises, if you have additional server, you can use it to take a logical backup out of it, or you can take the cold backups from it just to stop it, take the backup. Take the EBS snapshots, bring it back up online. And yes, so as I said, I'm going to give you a quick demo, but before that, I'll hand over to JJ for a second poll.
Yeah, thanks a lot, Krzysztof. So we wanted to ask you another quick question, which is, of course, on topic as well, and that's to ask what backup methods you currently use yourselves. So we covered pretty much all of these, whether it's MySQL dump, mydumper, xtrabackup, snapshots, or maybe you use something else. It'd be great to get your feedback here just to see what you're currently using. So I let this run for a few seconds. And also just to remind you that you can ask us any questions on today's content by using the question section of your control panel. We already have a couple of questions there, but feel free to ask more as your questions come up, and we'll take some minutes at the end of the webinar to answer those questions, of course. But for now, thanks for your participation in this poll. I'm just going to close this now. It looks like pretty much everyone's participated, so thanks very much. And I'll just share the results. So maybe not too surprising, but MySQL dump is widely the most used backup method, and it is very popular. Then xtrabackup and mydumper. Any comments on this? And snapshots? Any comments on this, Krzysztof, before you start the demo?
Yeah, I mean, well, as I said, well, the MySQL dump is the most popular one, and xtrabackup is also very, very common. Well, I think that's a good choice, I would say. I mean, as long as you're not taking MySQL dump backups out of very large data set, because then your ability to actually restore maybe, I mean, it will just take much more time to restore the data taken backed up through the MySQL dump. But I mean, as I said, it's just a very, very healthy combination. Physical backup taken through xtrabackup, and then logical backup taken with MySQL dump.
Great. Thanks a lot, Krzysztof, and thanks everyone again for your participation. I'll hand back over to you now for the demo, Krzysztof.
Okay, thanks, JJ. Okay, so let's take a look at the ClusterControl. So I have a cluster here. I mean, it's actually not really relevant, important. So but in this case, I have a replication cluster here. And let's take a look at our backup section. Okay. Yes. So as you can see a couple of backup sets. So, but first, maybe let's see what kind of backup schedule I have. So in general, with ClusterControl, you can schedule, you can build a backup schedule. So in this case, what I'm doing is I'm taking a full extra backup at 2 a.m. daily, and then I'm doing incrementals every hour. So I'm just taking, making sure that I have a backup every hour created. You can, of course, add something else. Maybe I want to have, let's say, a MySQL dump. I'm going to stream it to controller, and I want to, okay, sorry, let's just create backup. So this is actually how, if I would like to run backup right now, if I would like to schedule a backup, I can do it in a schedule backup window. So again, MySQL dump, store on the controller, all the databases, and let's say I want to run it on Sunday at let's say 5 a.m. I can schedule a failover backup if node is down. So let's say I want to take any, I mean, if this particular node, if this 0.106 will not be available, ClusterControl will attempt to select another host which is available and then run the backup, the MySQL dump on it. Then I can schedule this backup. And as you can see, it's shown in the backup schedule. So and then we have those backup lists and sets. So the set basically contains full extra backup, and then several incremental backups. And then you can restore either whole set, or you can restore up to some point in time. Like I can restore until, let's say, 6 a.m. To restore, I just pick where I want to restore the cluster, the backup, and then the cluster will be stopped, and there will be, the recovery will happen afterwards, and the cluster will be reprovisioned. So if you feel like restoring external backup, I can also, I can upload file to some location, and then I can, configure it, set the path to the backup, and attempt to restore a backup which was not taken by the ClusterControl, but some external tool, for example. And that's mostly about it. You can configure the backup retention, so the backups older than given number of days will be deleted. Of course, you have to balance it using depending on the backup size, so on and so forth. Because, well, if you have a larger data set, this could become that 31 days might be a little bit too generous. But as I said, it's up to you, depending on the backup set, size, depending on the volume size, and so on and so forth. So as you can see, you can do pretty much anything. You can set up the backups. You can restore them. You can create ad hoc backups using the create backup option here. So I can, let's say, mysqldump, create on the node, and then just here a new backup is being created, and I don't have much of the data on the host, so it's just basically empty. So it completes quite fast, yes. But what is also important, you can check logs, right? So you can either check the log here, or for the backup sets, you can check the log of every backup. Well, every incremental backup also that is that's part of this backup set. So that's how it looks like in the currently stable production version of ClusterControl. I would like also to show you the recovery feature that we are working on, and it should be available quite soon. So again, this is this development version of the ClusterControl. So what I can do is, when I try to restore, it looks the same so far, right? So I have a backup set, and let's say I want to restore here. And then you can pick, either you can restore on node, which is what I showed you just before, or you can choose to restore and verify this backup on a standalone host. So what happens is that this will be, we will create a new one, a new host, standalone. It will get the backup will be copied there, and the backup will be restored there. And then you can see how it works. Everything is fine. Then you can try to join the class, set up the replication to this from the existing cluster to this one, and so on and so forth. So I can do this. Then I need to fill up some IP. I need to press enter. So we are checking. So you have to have configure it with access from SSH access from the ClusterControl, just like you have with any node. Yes, I just used some random IP, so obviously SSH connection failed. But of course, ClusterControl has to be able to connect to this host using SSH and connect as root or using sudo, because then we need to install the software and then set it up correctly. So then you just click on restore backup, and basically the ClusterControl will copy the backup there, attempt to restore it, and it will let you know whether it was possible to restore this particular backup set or not. So basically that's it. So what a couple of documents, like resources that we have related to backups, including white paper. And before we take a couple of questions, I'll hand over to JJ for the last poll.
Yeah, thanks for that, Krzysztof. Yeah, so before we look at some of the questions you've been asking, we want to ask you, all of you, one last question for today, and that's whether you currently perform recovery tests yourself in your day-to-day activities with your databases, whether it's regularly or whenever you have the moment or the time to do it. Maybe you're not doing it regularly enough, as regularly as you would want to. Maybe you're not really doing backups, but you're looking at implementing processes for it. And hopefully you got some good insight today on how to do so. So I give this a few seconds for everyone to provide their feedback. And of course, you can still ask us questions as well by using the question section of your control panel. But for now, thanks for your participation in this last poll. I'll just close this now and share the results. Okay, so it's a 50-50 split again between some of you who don't really do backups at the moment, but you're looking to implement processes for it, and others who feel that they're not taking enough backups of their databases. So that's interesting. Thanks very much for that feedback. We do have a few questions that have been asked. So let me have a quick look here. There's a question here by Musen, and this is around whether they should run the dump software on the load balancer, or on one of the MySQL nodes. What's your take on that, Krzysztof?
Mm-hmm. So, I mean, it really depends on what kind of software you are talking about. So, for example, xtrabackup requires to be executed on the MySQL host, and then you can stream the data to some other location, but you need to run it locally. I would say usually you run the backup on the MySQL host, even if you could do it like from remote, because technically speaking, mysqldump, you can dump the remote server from the remote server to some other location. I think typically you run it on the MySQL node.
Okay, great. Thanks, Krzysztof. And there's a question here from Andreas, and he's asking whether it could be problematic if they use binary logs with xtrabackup, with the start date time and the end date time, instead of using the start position and the end position.
Yeah, I'm just checking, going through this question. So, I mean, in general, you want to use start position and position, because start and date time is not precise enough. So you can it could be that you are trying to, I mean, so it may happen that a couple of events happen at the same second, and the dates and date time is has a second granularity. So then the question is, what will be recovered and what won't be recovered? So you can end up with a case where you try to, I mean, overwrite or apply the transactions which are already being applied by the xtrabackup. But I'm checking if it's actually answered your question. So yeah, so I mean, if you're taking if you're recovering the xtrabackup, so you recover, as you said, you recover the full backup and then all incremental backups, then you should basically check the binary log position on which you are right now, and then from that particular position, recover rest of the data using mysqldump, mysql. So I think that should be it. And of course, the apply log, you're applying logs as long as after you during the recovery process, restoration process from the extra backup. So it's not really related to the point-in-time recovery. You just have to restore the full backup plus all incrementals, make sure that its lock is applied correctly. And then from that point, you need to figure out where you are at which position, and then from that position, you want to recover the rest of the changes using binary logs. I think I hope that this answered your question.
Great, thanks, Krzysztof. Yeah, and let us know, Andreas, if you have more questions or need more insight on that. Maybe one. So thanks, Andreas. So that did answer the question. Thanks very much. So maybe just one final question before we finish for today, and that's whether extra backup can work with data at rest encryption.
Yes. So, but there are problems with that. So in general, if we're talking about Oracle and Percona server, this will work just fine. But then, because the problem is that, I mean, in MySQL and Percona server, only table spaces are compressed, encrypted. So, and the extra backup just copies them. So this is not a problem. The problem is with MariaDB, and where they have also they encrypt also logs. So they encrypt random logs. They encrypt, if I remember correctly, even binary logs. So this is and then basically extra backup cannot work with this. On the other hand, MariaDB, for that particular reason, developed a fork of extra backup which supports, which works well with this kind of setup. So if you're running MariaDB, and if you're running using the data at rest encryption, you may be interested in using their own. I completely forgot how it's actually called. MariaDB Enterprise Backup or MariaDB Backup, something like that, which supports the data encryption for MariaDB.
Great. Thanks a lot, Krzysztof. And I think that's everything for today. I don't see any other questions. Thanks everyone for asking them and for your participation. Just to point you again to these resources that Krzysztof brought up earlier. So you've got our white paper on, it's a DevOps guide on how to do database backups. So feel free to download that from our website, of course. And you've got, we have a number of blogs all around the backup topic. And of course, you can always install ClusterControl if you haven't done so yet, and test all of its backup features there. So you've got the link here on, for the install script for ClusterControl. So feel free to check it out and let us know of any feedback you have on it. But for now, thanks a lot, Krzysztof, for the presentation today and for the demo. Thanks everyone for your participation. And we'll be in touch, first of all, with the replay details. So we've recorded the session and we'll make the recording available to you. If not tomorrow, then at the latest on Thursday. So you'll be able to go through the slides again and watch the session back if you so wish. And we'll be in touch with our next webinar, which should be at the end of June or in the first week of July. And it should be around DevOps, actually. It will be a DevOps topic. So look out for invitations for that, and we look forward to seeing you there again. But for now, thanks very much. Have a good rest of the day and talk to you soon. Thanks and take care. Bye-bye.